All right, today we're diving into something really cool, a groundbreaking AI model called Bolmo. What's so special about it? Well, it represents a totally different and, frankly, a much smarter way for AI to understand human language.
So let me just ask you something. Take a look at this sentence. How do you think a powerful AI actually processes those words? I bet the answer isn't what you think, and it really gets to the heart of a fundamental problem this new model was built to solve.
And this slide just lays it out perfectly. On the one hand, you've got the standard method. Most AIs break a word like international into common chunks, or tokens, like inter and national. But on the other hand, you see the new way. The Bolmo model looks at the most basic building blocks possible, the individual characters, or even more accurately, the fundamental bytes that represent them.
Now, this old way of using word chunks has been the go-to for years, but it actually comes with a whole set of hidden issues. This brings us to what developers call the subword problem. So, what even is subword tokenization? Well, it's the engine behind pretty much all modern language models. They basically use a fixed, preset dictionary of word parts and try to match any text they see back to that dictionary. It's pretty efficient, but as you're about to see, it's far from perfect.
And this right here shows you exactly why. Because these models have a fixed vocabulary, they get confused easily. A simple spelling mistake, a rare scientific term, even text in a different language can completely throw the whole system off. It's a surprisingly fragile way to deal with messy, real-world text.
Okay, so if subwords are the problem, what's the solution? Well, the answer is to build a more robust system that goes right back to the basics, and that's where the Byte model comes in.
A byte-level model is just fundamentally different. Instead of a dictionary with thousands of word parts, its vocabulary has just 256 possible values. That's it. That's all you need to represent all digital text. It doesn't need to know the word international. It just needs to know the letters I, N, T, and so on. This makes it universally adaptable to pretty much any text you can throw at it.
And this is where Bolmo's design is so incredibly elegant. First, it just reads the raw bytes. Then, it cleverly groups them together into these variable-length patches. Step 3 is the genius part. It feeds these patches into a powerful pre-existing AI reasoning engine. And finally, it uses all that context just to predict the very next byte in the sequence. Simple, right? So here's the crucial point. The creators didn't try to reinvent the wheel here. They took a high-quality model that already existed, Bolmo 3, and just gave it a new, more flexible front end. This quote really captures their strategy perfectly. Reuse what already works and innovate where it really counts. So it's an elegant design, and it solves a real problem. But that leads to the most important question of all, doesn't it? Is it actually powerful? Does this whole byte-level approach mean you have to sacrifice performance to get that flexibility? Well, the answer is pretty fascinating. Okay, let's start with efficiency. Because Bolmo is just upgrading an existing model, the training process is incredibly fast and cheap. In fact, it requires less than 1% of the massive computing power you'd normally need to train a large language model from scratch. That's an absolute game changer. So what about performance? This chart tells the whole story. You can see the original model, Bolmo 3, sets a really high baseline. And the new model, Bolmo, which is byte level, impressively matches its parent's performance. The key takeaway here is you get all the flexibility of a byte-level approach without a major hit to performance. And here is the number that might be the most incredible one of all. This model is so efficient that it can run using less than 6 gigabytes of VRAM. Now, to put that into perspective, that means it can run on a standard gaming computer, not some massive, expensive server in a data center. This combination of robustness, performance, and extreme accessibility, well, it points to a very exciting future. A future that might just be bite-sized. So why does all of this really matter? It means we can build AI that is far more resilient to the messy text of the real world. It means developing and fine-tuning powerful models becomes dramatically cheaper and faster. And maybe most importantly, it makes this technology accessible to far more people and developers. Let's put it all together. The big takeaway is this. By going back to the absolute basics, the bytes themselves, this new approach is creating a generation of AI that is simply smarter, tougher, and more accessible for everyone. And that leaves us with a final provocative thought. When AI can truly understand language from its most fundamental components without any shortcuts, What other complex problems will it be able to solve from the ground up? What comes next?